Hi. You've seen already how CA-ARD can model processing software, but what I'm going to look at now is how it can model business processes, but also link the higher level business processes to lower level software and systems processes, and how it can model and manage end-to-end testing in a realistic scenario. So first I'm going to talk about business process modeling in the round, and then look at workflows and how they drive testing. We'll talk about end-to-end testing, and then I'll show how ARD can model and test a rail traveller's journey. Now, with business process modeling, or BPM, graphical representations of business processes have been around for a long time. In fact, the first mention of them is in the 18th century. Process models are often layered and hierarchical, and by that I mean you might have a high-level organisation-wide business goal or activity. Beneath that you'll have processes which the business employees use to implement and achieve their goals. And then beneath that you might have workflows within simple business processes, user activities if you like, workflows, which actually reference the systems they use and to actually how they use them to do their job. Now, you've seen how CA-ARD can model systems, processes and flows, and modelling a business process opposed to a software process, there's not a great intellectual step here. But what's interesting now is that ARD can integrate high-level processes with lower-level processes, so high-level flows with lower-level workflows. Now, as part of the features of ARD, the optimizer can see into these lower level processes, if you like, and to generate paths based on both the low and the high level models. Now, typically, user and acceptance testing follow paths through business processes or workflows, and the goal of this is to test the system in the context of the user's activity, if you like. So one way I look at these things is workflow testing is also really an integration test. It's a test of the integration between the user's processes and the system processes and features that support the workflows. Now, in projects, we often see serious system problems emerge very late, because when the user starts looking at the system in the context of their daily work, they see all sorts of issues in the software that just haven't been considered. So it's common nowadays that system tests include workflow-based tests to catch these problems a little bit earlier. Now, there's a lot of confusion in terms of terminology in this area, and end-to-end testing is this one label for what has been called link, workflow, string, transaction flow, scenario, user, use case, acceptance testing. All these things are very similar, and it's hard to tell them apart, I have to say. What I'll do is I'll use end-to-end or E2E as a label for these tests from now on. Now, end-to-end tests usually derive from a two-layer model. It's kind of simple, if you like. The high-level layer describes the user workflow, and this is the process, the activity the user undertakes in order to achieve some goal. The lower-level layer are usually models of the actual system features or transactions that the user actually uses in the workflow. Now, CA-ARD can model a high-level process as a hierarchy of sub-processes, and I don't think there's a limit to how deep these processes can go, and certainly it'll allow us to do end-to-end modeling and testing. Now, what's really clever is the optimizer generates paths that include the high-level process, but it can see down the hierarchy into the sub-processes and actually generate an all-paths optimization based on all the features and all the decisions made in all the processes in the overall model. So at that level, it can create extremely comprehensive paths. But on the other hand, it's also got features to manage and customize these optimizations, so you can manipulate the optimizer to give you the outcomes you want, and you can test at a very high level or a detail level or some kind of hybrid. Now, I want to demonstrate the tool, but just let me explain the model that I'm going to create for you and show how it works. This is going to be a model of a workflow for someone taking a train journey. And essentially, the process is you search for a train to go from A to B. You buy your ticket, maybe with a rail card, maybe not. And then at some point you go to the station, board the train, go to your destination. In terms of the modelling, there are actually 5 models I'm going to show you. So the high-level master flow, if you like, is I've called journey workflow. This is the highest level, and you can see this is the story at the highest level. There's a model for the searching to find a train. There's a model for the buy ticket process. And actually, there's a further subflow, which is making the payment using a card. So buy ticket actually is its own master, and it's got a subflow as well. Finally, make journey is actually using the ticket to actually make the journey. Okay, so here we are in Agile Designer again, and let me show you the high-level model first of all, and just to see how the whole picture kind of pans out. So here you have the journey workflow, and I'll go through it very quickly, but what I'm going to do is recreate this from scratch so you see how it works. We have a plan journey activity, which is basically the start of the whole process. We search the train schedule to find a train. We select a train. If that's true, we buy the ticket. We buy the ticket and we pick our day of the journey. We start with plan the journey. We search the train schedule, and you can see this is a subflow decision. The outcomes from that decision, train selected, not selected. We have a feedback loop if there's no train selected. We have another subflow, which is buy the ticket decision, yes, no. We carry on. On the day of the journey, we make the journey and we go to the destination. So I'm going to sort of walk through the subflows first and then recreate this master flow, what I've called the end-to-end journey workflow. So the first subflow is this one, search the train schedule. So again, we have a search for a train. We need to choose a valid departure station. We have a destination station, a journey date, a train available on the report from the search, and then we choose the train. So at each stage we can kind of bail out. So we might decide not to pursue this at all, not even look for a departure station. Destination station, journey date, in effect these are all validations. At this point, the train available, yes, no. If there is a train, then I can choose it, yes, no, train selected. Now all the other options to bail out or where there's an issue, we have no train selected as an endpoint. And the important thing to realise that when you create a subflow, if there is a positive and a negative, or maybe there's alternative outcomes, we should have an endpoint for each one of these, because this is how the master flow will connect to the subflow. So this is fairly simple. So what I'm going to do now is just look at the Path Explorer, and I'm going to select all possible paths, and I get 6 paths. That kind of makes sense. There are 5 decisions to bail out or have an error, and then there's 1 path which gets you to the very end with a successful outcome, train selected. I won't save the paths because I've actually already done that before. So now let's look at buy ticket. This is the second process in the journey. So if I start, and the question is, do we want to use a rail card? There are 3 choices: no rail card, over 60, and a young person's rail card. We then have another subflow here, which is whether we make the payment successfully. So we have an opportunity here to bail out, and here we have a subflow which is making the payment, which might succeed or not succeed. So we have, from the start point, we have 2 outcomes of this sub-process: got ticket or no ticket. Now the make payment sub-process, let's have a look at that one. That's this one here. So make payment, we have start, we have a card type, there's 5 card types we could select, valid card number, valid expiry date, security code, and then accepted by the payment service, and the payment is either rejected or it's accepted. So again, I've got 2 outcomes. The payment is okay or not okay. So back to our by ticket process. Again, it's a simple process, and I can look at the Path Explorer, and I'll look at all possible paths, and we get 32, which is kind of interesting given that it's a very simple model. What's going on here? Well, in fact, in the make payment sub-process, let's look at that again, we have the potential here. If I go into Path Explorer, all possible paths, 25. So most of the paths in the make payment process have come or derived from the paths through this. Now, when you connect a sub-process to a master process, the default integration, if you like, and how the optimizer will work is it will take the saved cases and use those as the basis for calculating paths in the master process. So in the by ticket process here, you can see in the subflow integration, I've got stored paths. So it's going to use the stored paths to build up paths in the master process, and that's why you get this rather large number of 32. And you see again that I've stored those test cases. So this is an important consideration. The optimizer, and ARD in particular, connects sub-processes with master processes through the outcomes, in this case no ticket, got ticket, and it uses one of several strategies to build up the optimizations, and as you can see, it can calculate them in an ad hoc way. You could actually say always use full coverage in the subflow, or use the stored paths. I'm using the default, which is stored paths. We can look at the other options a little bit later. So the third aspect of the journey is making the journey itself. So here we've got from the start, are you at the station? Yes, no. Have you got your ticket? Yes, no. Are you in time to catch the train? Yes, no. If you fail in any of those stages, you go home. Otherwise, you get on the train and make your journey. So again, we've got 2 outcomes: go home, make journey. So here's the highest level workflow, and what I'm going to do is build that up from scratch. So I'm going to start with a blank model and then just show you how the process works as you integrate processes one inside another. So we'll create a new model. We'll call it end-to-end journey. Okay, so I'm going to make it simple, pretty much. Plan journey. You need an activity at the top in order to loop back, and I'll link that. And okay, so the first decision, subflow decision, is going in here. This is the find the ticket, do the search. So my source is a file. Okay. Okay, and the file is where are we? Oh. Select train. And the first sub-process I'm going to add is select train. Okay, and ARD reminds me that there are 6 stored test cases, and I could use one of the other criteria, but my cases are stored as test cases, so I'll say yes to that, and here it is appearing in the model. So now in here I've got 2 outcomes, search train schedule, true or false. So I'm going to suggest I have a decision here, which is selected train. So when I go from one to the next, I'll say both. So I have two links there. And now I want to go to the stage of buying the ticket. So we have another sub-process from a file, buy ticket, that one. It's got 32 test cases, okay. Join the dots. Again, we'll have the true and false both going through. So now we'll add the sub-process for buying the ticket. Okay, and it's that one. And the test case is 32. We know this is including the detailed card purchase. So we'll have a successful path there. And I'll create a feedback loop from buy ticket to plan journey. Perhaps I decide I don't want to go after all. Perhaps I fail to make the payment and I don't get a ticket. That's okay. So now I need another decision. Bought ticket. Make some space. So from bought ticket to the decision, I'll take both outcomes. I'll make some more space. So from bought ticket, one will be a successful, let's carry on. The other one would be, I didn't buy the ticket, I've got to go back to plan the journey, and that would be the false outcome. Okay. Next, I need a decision on the journey date. So here is the question day of journey. And we'll connect to that. If that's true, I'm going to make the journey. So I've got another subflow decision here, which is make journey. 4 paths, 4 test cases there. So that's the true outcome. It's the day of the journey I want to travel. But it might be that actually it's not the day of the journey. So I'm going to have another endpoint here, and I'm going to call this wait at home. So the false outcome would go here, which would be go home. And the true outcome would be to make the journey. And pretty much that's my model. So this is the whole model end to end. And if I go back to my previously prepared one, you'll see it's the same. Okay, so the next thing I need to do is there are a couple of constraints required to eliminate impossible paths. So if I go to constraints, the first one is if I don't select a train, I shouldn't be proceeding to buy the ticket. So let's do this one. Must not occur together. No train selected. Can't buy a ticket. And the other one is if I haven't got a ticket, I can't proceed to take the journey. So no ticket and no journey. Okay, so those are our constraints added now. Okay, so let's go to the optimizer and look at all paths, see what happens. Okay, so we get 11. Now there are 11 because the optimizer is taking into account the subpaths, and for example there are 5 credit cards which account for 5 of these paths, and then there are 3 rail cards, or there's 3 rail card options, 2 with, 1 without, and then there are 3 ways in which we basically don't get the train, which are the responsibility of this make the journey sub-process. So 11 paths sounds reasonable, but I know there's more, because what I've not done yet is taken account of the 2 loops that are in the model. So let's just put 1 insertion for each loop, and then we'll run the all possible paths optimization again, and we get 20. So here we have 20 paths in total. The feedback loops are exercised as well, so when we go back to the start, if you like. So that all sounds reasonable. So what I want to do now is to just make a couple of observations of what's going on in the optimizer and the paths that are generated. If we take a look at the by ticket sub-process, you can see we make a choice of railcards and then we have the make payment. Well, let's look into the make payment sub-process. And in here you can see we've got 5 credit cards, and then there are 4 ways of bailing out of the process, and then a success. So there are 25 combinations of paths in this model. Why weren't they all taken into consideration? Surely we should have 25 times as many paths in the overall journey. Well, the reason for that is, of course, that we only included the loops to exercise once. So all these failure modes don't get taken into consideration, because only one failure loop back to the start is allowed by the optimizer. But the other thing is that you can see that the 5 credit cards that are quoted here, we did see 5 test cases with the different credit cards. So what I'd like to do is to limit the number of credit cards that are actually used in the optimizer for the entire journey. So if we go into Path Explorer for this model, you can see there's the 25 test cases that we saved, and that's what's being used. But let me just show you something. If I look at only covering all nodes, I get 2 paths, and these 2 paths reflect 1 success and 1 failure. So if we go to the parent process, so we have make payment, let's go to the buy ticket process. In here, suppose we change the subflow integration to all nodes. So what this will do is it'll change the mechanism it uses to include all the paths from the sub-process. So it's not going to use the 25 saved paths, it's going to use just the 2, 1 success and 1 failure path for that sub-process. Now, for the parent process to take the new configuration of this process on board, you have to save it. So I'll do that now. Save to file. Okay, so that's saved. So let me now go to the overall master process, and what you'll notice is on the bottom right I've got a notification saying subflow update available. So if you click on the status bar just beneath the, so you can see there's 1 update to absorb into the parent process. So we have this button, reload direct subflows. Okay, so now this is up to date. So in order to take just a limited number of paths from the sub-process, I'm going to choose all nodes, apply that, and now when we're going to Path Explorer, I'll look at all possible paths, we'll take one route through each loop and see what that produces. So there we have 14 paths in the overall model, and what we've seen is that we can control the number of paths observed at the top level process by either using saved paths in the subprocesses or by using the integration option for each subpath to influence whether you take all the paths or whether you have a less stringent optimization. So between the parent processes and the lower process, you can basically juggle with the coverage that you want to achieve any end you like. One last thing, why would I justify the reduction in the number of paths through the payment process, for example? Well, what I'd expect to do would be to test the payment process with the credit cards quite thoroughly in isolation. So when I integrate that tested payment process into an end-to-end kind of workflow, I wouldn't worry too much about having to retest all those combinations and permutations of credit cards and failure modes, because I would have already done that in an earlier test activity. So we've seen that ARD can integrate subprocesses with parent or master processes to model business workflows and software features all working together. Now the optimizer can see into the subprocesses at any level, and you can either reuse stored paths in the subprocesses or use an ad hoc optimization. And in this way you can increase or decrease and tune the number of paths generated at the parent level. Now we should be testing system features like our payment process with credit cards. We should be testing these features thoroughly in isolation before they're integrated into an end-to-end test. So we don't usually need to bring all their tests into the parent processes. So we can pick and choose where we want to focus in our end-to-end tests. We have control over where we pay attention. So you can see now that ARD can support modelling and testing at the system feature level all the way through to an end-to-end or acceptance stages in your projects.